In this video, I will discuss total white blood cell count. Total white blood cell count by hemocytometer. WBC count is a blood test to measure the number of white cells in the blood. Principle: whole blood is mixed with dilution fluid. Lyse the red cells and stain the white cells nuclei deep violet black by the dilution fluid. Count the cells by using hemocytometer. Calculate the total number of white blood cells. Requirements: pipettes, improved Newber counting chamber with cover glass, microscope, vortex mixture, reagent, Turk fluids or WBC diluting fluid. 100 ml of WBC diluting fluid contain 2 ml of glacial acetic acid to lyse the RBCs, 1 ml of 1% gentian violet to stain the nuclei of the WBC, and the distilled water. Sample: whole blood EDTA sample and the capillary blood sample. Procedure: check the clots of the sample. Well mix the sample in gentle manner. The dilution is 1:20. Mix 0.1 ml of blood to 1.9 ml of dilution fluid in clean dry tube. This is the macro dilution method. For the micro dilution method, mix 0.02 ml of blood to 0.38 ml of dilution fluid. Mix the diluted blood by a vortex mixture to ensure the complete hemolysis. Clean the counting chamber and the cover glass properly. Place the cover glass on the grid area and carefully position the tip of the pipette on one edge of the cover glass. Allow the content of the pipette gradually flow into the narrow space between the cover glass and the counting chamber by the capillary action. You may fill the other side with the similar manner. Leave the chamber undisturbed on a bench for 2 to 3 minutes for cells to settle down. If the mixture is overflow or the air bubble forms, then clean and dry the chamber, remix the contents of the tube and refill the chamber. The bench must be free of vibrations to settle down the cells. Chamber must not be dried before counting. Now the chamber is ready for the microscopic examination. First, locate the grid area under the lowest magnification 4x. After focusing the objective, turn the objective to low power or 10x. Then adjust the light intensity to visualize the ruled area and cells properly. Check the distribution of the WBC in 4 corner squares. Recharge the chamber if distribution is not uniform. Now you can start the counting of the cells. These are the 4 corners of the WBC counting squares. This is one WBC counting square under the low power of the microscope. In previous video, I discussed the counting rules for the WBC counting. Calculation: area of the 4 WBC squares equal to 4 into 1 millimeter into 1 millimeter equals to 4 squared millimeter. Depth of the chamber is equal to 0.1 millimeter. Volume of the 4 squares is equal to 4 squared millimeter into 0.1 millimeter equals to 0.4 cubic millimeter. Here we consider the total number of cells in 4 large squares are n. Therefore, Total white blood cell count equal to number of cells counted N multiplied by dilution factor divided by the volume content. Therefore, it is equal to N multiplied by 20 divided by 0.4 equals to N multiplied by 50. Normal white cell count is 4 to 11 into 10 to the power 9 per liter. At birth, the total leukocyte count is high. There are also slight sex differences. A moderate leukocytosis can be seen during the pregnancy. Falsely high counts can be occurred due to improper mixing of the sample or the dilution fluid and the blood, error in pipetting, overflow of the chamber, uneven distribution of cells, presence of nucleated red blood cells, presence of malaria parasites, and error in calculation. Falsely low counts can be occurs due to clots in the sample, improper mixing, error in pipetting, incompletely filled the chamber or underfilled the chamber, uneven distribution of cells, clumping of the cells, and faulty technique of counting. Thank you.